Hi, welcome to the lab once again. It has been a while since I posted, and so I have been engaged in something, and I have had not enough time to work on electronics. So what I have today is this power supply. It's an ATX computer power supply. ATX stands for Advanced Technology Extended, which is a motherboard and a power supply configuration. I think it dates all the way from the 1990s, around 1995 thereabout. And so this is the standard form of power supply you'll get in most desktop computers. And my power supply here is rated at 650 watts, so that is quite some power. And in order for your computer to work properly, there is a few voltages that the motherboard needs. So you will have your voltages written somewhere on the power supply, like this one. They are well indicated on this sticker. So you have your 3.3 volts at 35 amperes, 12 volts 25 amperes, minus 5 volts at 0.5 amperes, so plus 5 volts at 40 amperes, and so on. So what I want us today to do is we look at it and learn how this power supply works. So let's see what powers your computer. So we have a set of screws that need to be unscrewed. So the cover is off, and this is how it looks from the inside. So that's how it looks, and in order for us to understand well how it works, we need to draw a schematic diagram. So we follow the voltage all the way from the input up to the output point. So let's do that now. This is the basic layout of this power supply. So first thing first, you need your input. So your input might be from 120 to 240 volts depending on where you are. So 120 VAC or 240 VAC. This is where you get from your wall socket. So your input needs to be fed through a filter and a rectifier. So the first stage will be your filter. So filter and rectifier. So after that, you will have your clean DC volt, which is a high voltage DC. So your output from this stage will be DC. Okay, since this is a switch mode power supply, your DC will be fed to a switching circuit. So this is your switching circuit. So mostly you'll find you have transistors here acting as switch. You can have one or two depending on the topology used in your power supply. So then this voltage is passed through a transformer. So this is a smaller transformer as compared to what you will find in linear power supplies, and also it is a high frequency transformer. So from this transformer, so this is our switch. Switching circuit, and it will switch this DC voltage at a frequency of around from 15 to 50 or to 120 kilohertz depending on the application. So then your output, your stepped down output, will be fed through another rectifier. So this is the output rectifier. So you get your DC output. So here you might have a couple of outputs depending on the application. Like in our case, we have like 12 volts, 5 volts, 3.3, negative 5, and so on. Then you'll need to monitor what's happening at the output and control your switching depending on what is happening at the output in order for you to stabilize the output. So in that, so you will have an output sensor here, so for sensing the output voltage. So output sensor. Then you need, since you don't want to connect these two parts, since there is an isolation here, you need to isolate the primary side or the high voltage side from the low voltage side of the power supply. So you need some kind of an isolation here. So you should have an isolation. In most cases we use optocouplers as our isolation. Then you need to connect this through some kind of an amplifier known as an error amplifier. So this is a sign for an amplifier, and this amplifier might have a reference, something that you are referring to, okay, in order for you to correct the switching. Then this will be fed through, or will be fed to our oscillating circuit. So this oscillating circuit is what controls the switching. So this will be our PWM oscillator. So this is the basic layout of a switch mode power supply, and this circuit here is what is known as our feedback loop, or whatever you may call it, feedback. So you are giving feedback to our oscillator in order for it to control the switching. In this way you'll be able to regulate the output to its intended characteristics. Now, having known this, let's look at our power supply and try to figure out where these stages are. So for the first one is our input. So our input is at this point. Our input is at this point. So you get your AC from the socket through this. So these two wires. Then you'll have so this one is a resistor NTC. So this one, what this does is it reduces the inrush current to our power supply. Then you have these capacitors. These two are used to filter the input. So it varies with circuit. You might have another circuit that has a big inductor here, coupled with a few capacitors. Then that voltage is fed through a switch. Of course, we all know the work of a fuse is to break the circuit whenever something goes wrong upward that circuit. Then this AC is fed through a rectifier. Our rectification happens here. So you see we have 4 diodes. So in a bridge rectifier configuration, then we have our filtering capacitors, the 2 capacitors. So now, depending on the topology used, you might have 1 or 2. So in this case, the topology is a half bridge. So we have 2 capacitors creating some kind of a differential voltage. So you will have a ground, negative voltage, and a positive voltage with the reference to ground. So the point, these 2 capacitors are connected in series, and the point where the 2 capacitors meet is our reference point, so our ground, okay, or our 0 voltage point. So after that, we have a clean DC voltage from these 2 capacitors. This clean DC voltage, so that clean DC voltage is then fed to our switching circuit. So now in this topology, we have 2 switching devices. I don't know whether you can be able to see them. So the 2 transistors, so these 2 transistors are our switching devices. So after that this high DC voltage is switched through this transformer. So this is the big transformer here is our high frequency transformer. Then we get our output from this transformer. So all your outputs are from this transformer. So the output is in AC, still in AC form. We need to pass that through our output rectifier. So for the big this is a diode, the big one. I think it switches the 12 volts, or it rectifies the 12 volts, and this is a high frequency diode. Then that rectified output voltage is fed or is passed through an inductor. So this inductor is for more filtration, then through a capacitor, then through these output wires. Okay, so this is where you get your clean output voltage. So the same happens to all the outputs. So you have your 3.3 and your 5, the same happens to it. Now, so we have gone through the filter and rectifier, switching circuit, the transformer, the output rectifier, and so let's see our PWM oscillator. So our oscillator, our oscillating circuit is here. So this big IC here, this is our PWM generating IC. So this generates a PWM signal which is fed through our small transformer here. So this transformer is known as gate drive transformer. This one is for driving the bases of these transistors or the gates of in case where the MOSFETs are used, so for driving the gates of those MOSFETs. So this part, including the gate drive transformer and this IC, so this makes our oscillating circuit. Now the outputs from this power supply is also fed to this IC in order for the proper monitoring and regulation. So I think we have gone through all the parts of this circuit, and also in this case you might find that we have another small transformer here. So this small transformer here is for our standby power supply. So this power supply has is two in one. So we have the main power supply for providing the main power to our computer. We also have a smaller power supply which has two functions. So the first one is providing voltage to our, or rather providing power to our oscillating circuit. Okay, the second one is providing standby power to our computer. So at the output of this, we'll have like 20 volts going to our oscillating circuit and 5 volts going to our computer, which is our standby volts. So if you look at this, you will have 5 volts standby at 2 amperes. So this voltage will always be there even if the power supply is off. Okay, so I think we have gone through the parts, all the sections of this power supply, and so we have some heat sinks here for cooling our switching devices and also our diodes. I think I hope you have learned something from this, and you might be asking yourself where or how you can use one of these apart from it being inside your computer. So you can use this for various purposes depending on your voltage requirements. So you can use this to power your amplifier. You can use it to charge your phone since it has a very powerful 5 volts output. You can also make some kind of a bench supply if you work on electronics. This will be very helpful, and its output is very clean, having gone through all those filtration stages. It gives you a very clean output voltage. So I think I'm done, and maybe in order for us to get into more understanding of this, I'll go to the market and find a damaged one, and maybe we can do a repair video while explaining about it. So if you get one of these, take caution. Don't go ahead and open it. There might be some remnant charge on those two capacitors, which can be very hazardous to you. So you might get shocked. So take precaution, and if you are not sure of what you are doing, do not attempt to open this. So this was strictly for learning, and I hope you don't get yourself into some kind of danger because you watch this video and then you decided to do it yourself. So it's just for learning. Please take precautions. So see you in the next video.